The urgency of getting to net zero by 2050 means we have to deploy all possible solutions available to us. One of these solutions is carbon capture and storage, which has been mired for years by high costs that has made it uncommercial thus far. But the world will still need oil and gas for many decades to come. And for that to be viable in a net zero future, we need CCS to work at scale. For this to happen, the technology requires a number of issues to be resolved, mainly its high cost, the absence of regulatory support, and the lack of infrastructure. To discuss these challenges and examine the potential impact carbon capture could offer, I am joined by Dr. Julio Friedman, Senior Research Scholar at Columbia University's Center for Global Energy Policy. Thanks, Dr. Friedman, for joining us on the show. Let me start by asking you this. Carbon capture is definitely a valuable climate change mitigation tool, but will CCS be useful at the margins for a few specific applications, or will it be a central tenet of the global shift to net zero?
I'm delighted to be here. Thank you for asking me. I believe that carbon capture will be one of those things we apply across the economy. It has applications for real in the power sector, in transportation, for making hydrogen, for CO2 removal, but its best application and its most useful climate application will probably be in heavy industry, in refining, in steelmaking, in cement and concrete. These sectors we have very, very few options for. I also believe it will prove important to do things like decarbonize the aviation sector or the shipping sector by helping us scale the production of hydrogen and by helping us remove CO2 directly from the air and oceans.
Dr. Friedman, state intervention is paramount for supporting the nascent carbon capture industry. What do you think is the best way to go about that? We have direct funding, carbon pricing, tax breaks. What's the best supportive government policy mix, you reckon?
The best and most important policy for carbon capture support is whatever can be legislated. I'm quite serious about this. In the United States, we seem to do things through a combination of regulation of emissions from the EPA and tax policy through Congress. In the European context, they tend to do these things with feed-in tariffs, primarily. In the United Kingdom, a contract for difference mechanism is important. In Canada, they use a combination of all of these things, both a high carbon price, which is a $170 carbon tax, which has just been approved by their Supreme Court. It is also things like the grants, which they have given for demonstration projects and for infrastructure build out. All of these are very important to get the technology deployed. At its heart, the technology is not too expensive per se, but it is very hard to finance. You can't make your money back investing in it because there is not sufficient policy support. In this context, anything that can do the job works. That includes, by the way, creating enough market pull for low carbon materials. Today, for example, the Japanese government is willing to pay a premium for low carbon ammonia. And in that context, if it is made with carbon capture, with hydrocarbons, what is sometimes called blue hydrogen or blue ammonia, in that case, they have a government policy in Japan that is paying a green premium, and that higher green premium is in fact enough to pay for the carbon capture and storage enterprise.
Of course, CCS remains a crucial technology, not only to remove, but even recycle CO2 from the atmosphere. Circular carbon economy was adopted in last year's G20 summit under the Saudi presidency. What are some of the major applications of CO2 recycling, and more importantly, what are its limits?
Thank you. We just published a report on this a few weeks ago. Some applications for CO2 recycling are commercial today. For example, putting carbon dioxide into concrete and cement manufacturing, these sort of novel formulations from companies like Carbon Cure or Solidia or Carbon 8. These already are at commercial parity with what the market will provide. One of the more surprising ones we found was commercial already for CO2 recycling was carbon monoxide, which is in fact a rather large volume commodity traded around the world. And for that, the electrochemical pathways, electrocatalysis and so forth, are very close to market parity today. For other applications, we're not quite there. Other applications, perhaps something like olefins, something like methanol, we are not quite at market parity, but those are large and substantial markets. Another one is urea, for example. We can start recycling CO2 in those markets through, again, a combination of government incentives and policies to pay a green premium to bring more of that technology into the market. These technologies are often still very early days. A couple of them are quite advanced, but many of them are still at sort of pilot scale. And so in order to really garner investment, it's important to get more policies in place to bring those recycling technologies into the market. We estimate that you can get on the order of 3 to 6 billion tons a year in the CO2 recycling market.
So what are some of the most interesting carbon capture removal technologies out there currently? And more importantly, how are they faring in moving down that cost curve lately?
This is an exciting area. The technology has progressed very rapidly, and the costs have dropped equally rapidly. The costs have dropped profoundly in just the past few years. One class of technologies that have moved very quickly are sorbent-based technologies. These have in the past been solid amines. Increasingly, we're seeing things like metal organic frameworks becoming of interest. These can be used for point source capture. There's a company, for example, called Svante that does this, or it can be used for direct air capture. There's two companies that do that today, Climeworks and Global Thermostat. But these have really improved in terms of the speed and volume of production and have led to dramatic reductions in the capital cost of these technologies. In some cases, as much as 80 or 85% drop in the capital cost of the technology. There's also some other technologies that are just around the corner that we're beginning to see mature. One of these is electrical swing adsorption, using changes in electricity voltage to pull CO2 out of solutions or out of the air. There's also cryogenic technologies, essentially freezing CO2 directly out of flue gas. And we're starting to see these technologies scale and pilot. They have very promising characteristics. Among them, they're entirely electrical. You don't need heat. So in a world dominated by renewable power, that can become interesting. Also, as renewable power gets cheaper, their costs get cheaper because their primary costs are the electricity costs. Many people imagine CCS as some static, hulking, big, heavy industrial process. What we're seeing instead is people are moving towards these electricity-based, modular, small footprint technologies. An interesting byproduct of all of these technologies is that they release fresh water, that you have byproduct fresh water from their operation. In some parts of the world, notably in the Gulf states, this can be a very valuable aspect of the technology.
Absolutely, indeed. Speaking of the Gulf, one of the biggest sectors here is oil and gas. How would you characterize the oil and gas industry's efforts in general, thus far, globally, with regards to CCUS? Has the industry stepped up its game on that front, you think?
This is a tricky question because I believe the oil and gas industry has stepped up its game. It's been heterogeneous. Some companies have been more proactive than others on CCUS. For example, Shell, Total, Equinor, BP, Occidental Petroleum has been a leader. We've begun to see companies like ADNOC and Aramco get more into this carbon capture technology arena. That's all very welcome. I would also say it has been very slow and it is nowhere near large enough. This industry must create an industry of equal scale. The oil and gas industry creates 5 billion tons of CO2 every year through the use of its products. We have to have on the order of 5 billion tons a year removed through CO2 capture in a circular carbon economy. I understand that today it's very hard, again, to make money doing that. But the industry really needs to take more shots on net. They need to spend more money on pilots. They need to spend more money on infrastructure. They need to build hubs and centers to do industrial carbon capture. And they have to find new markets and new partners. As I said at the beginning, heavy industry is a really important application for carbon capture. That is an opportunity for oil and gas companies to have new markets and new partners. And we're beginning to see that today in the steel industry in Europe, in the cement industry in the United States, in the chemical industry around the world. We're beginning to see a little bit of oil and gas partnership with these new areas. In some cases, just retrofits, but more importantly, we're beginning to see zero carbon hydrogen emerge, both blue and green hydrogen. And the blue hydrogen is something where you can scale very quickly, and the oil and gas industry has a terrific opportunity.
Let's talk more about hydrogen, Doctor. It is touted to play a big role post-2030 in the global energy transition, but the challenges ahead are huge with a massive price tag attached. So what is first the required infrastructure, and should hydrogen's future necessarily incorporate blue hydrogen in addition to green?
We really are going to need huge volumes of hydrogen. I don't see how we get to a net zero world without it. And it has to be zero carbon hydrogen or near zero carbon hydrogen. That will require terrific investment, as you said. And again, policies are going to be very important to do that. We're starting to see policies in Europe to pay a green premium. I've mentioned Japan already. We're starting to see that in the US, for example, a production tax credit for low carbon hydrogen. In this, we need enormous amounts of infrastructure. And in fact, we are about to release a paper that details this. And it will be trillions of dollars worldwide. But that's the work. We spend trillions of dollars worldwide on other things. This is one of the things we need to spend trillions of dollars on. And the infrastructure will be a mix of blue and green. We will definitely be building dedicated renewables. The NEOM project in Saudi Arabia is an example you're probably familiar with.
True.
Where Air Products and ThyssenKrupp and Aramco are working together to make green ammonia. That is a enormous project. $5 billion on the ground, $2 billion of infrastructure, but that will make money today. And we're going to see more and more projects like that. Blue hydrogen is not 100% required, but as I said at the beginning, the value of carbon capture is it saves money. You could do it much cheaper than green today. In fact, in most markets, blue hydrogen is 2 to 6 times cheaper. That is a big advantage. It saves time. Today, the world's largest green hydrogen project is 2.5 tons per day of production. Today, the largest blue hydrogen project in the world is 500 times that size. So if you want to get a lot of blue hydrogen to the market, you can do that quickly. And it lowers the risk. We do not have in green hydrogen today global factories that make electrolyzers. We do not have all of the systems and balance of plant in place we would like to see to scale this globally. We do have that for blue hydrogen. You can buy autothermal reformers and steam methane reformers today at whatever scale you want and make very large hydrogen plants, 2 million tons, 3 million tons, 2,000 tons or 3,000 tons a day, quite easily. You may have seen in Canada, a new project was announced that was going to be a 2,000 ton per day blue hydrogen project.
Yes.
And that will be up in just a couple of years. So I see in the future, we're going to have a mix of green and blue hydrogen. It's what I call an aqua culture. And whether we have more hydrogen that's blue or more hydrogen that's green is really up to us. We are going to determine how much money we put into these things, which policies we prefer, where we will build infrastructure, and how big we will make it. That will really determine the future of hydrogen, and with it, the future of the oil and gas industry.
Dr. Julio Friedman, it's been an interesting chat. Thank you very much for joining us on the show.
It was a sincere pleasure. Thank you so much.